So our next function, we're going to look at a different function. We're going to look at the root function and see what steps we need to do. So in the last example with the rational function, that fraction, we knew that in order to get past, or the step we had to overcome was to do common denominator. In this case, there's another step we're going to have to overcome, and that's dealing with the root sign or the radical sign. So we're going to go away and plug away. This time we're doing x equals 7. I bet there's a reason why I chose 7 and not just some random number like 3 or 2. Let's find out. So we're going to find the slope is found by taking the limit as h approaches 0 of f at 7 plus h minus f at 7 all over h. So I'm going to plug in 7 plus h into our function. 7 plus h minus 3. And then minus, I'll put this in square brackets, even though the radical signs kind of act as the square brackets. 7 minus 3 all over h. This is going to simplify to the square root of 7 minus 3, which is 4. Plus h, so that step was right here. 7 minus 3 is 4. And over here is the square root of 7 minus 3, which is just 4, all over h. Now you're going to notice the square root of 4 is actually a nice number, and we could take it and get that the square root of 4 is 2. But I'm going to leave it as is because it's going to affect the next step I do. It's also going, you're not always going to get a nice number like 4. It might be a 7 or a root 3 or whatever. So we'll see what happens in this case. Now, there isn't a lot I can do. In the question before, I could take common denominators to bring the things together. But bringing in these radicals are very different. They're difficult. So what we're going to do is this step is going to be to multiply by the conjugate. So the conjugate is something that is a term we learned from last year in grade 11. The conjugate is a similar looking radical but has the opposite sign, and it will perform a really neat operation. So what I'm going to do is multiply by the conjugate of this top radical. So it's still going to be 4 plus h, but instead of minus root 4, it's going to be plus root 4. It's going to multiply by that conjugate. Now, I'm not allowed to just multiply a fraction by some number. That's not allowed. But I can multiply it the same thing on the top and the same thing on the bottom, and that is allowed. By multiplying by the same thing on the top and the same thing on the bottom, it actually means I'm multiplying by 1. This is a very complicated looking 1, but essentially it's a 1 because it's just the same thing on the top being divided by the same thing on the bottom. And multiplying by 1 doesn't change my question. But what this is called the conjugate. So I'm going to do this multiplying. I would normally do it off the side on the chalkboard, but for the purpose of this video, I'm just going to do it underneath and erase. So you can just watch this part. Okay, so this part is meant to be off on the side. I'm going to do root 4 plus h minus root 4 times the conjugate, 4 plus h plus root 4. Okay, see what happens when I do this somewhat complicated math. First thing is I have a radical being multiplied by its radical itself. So remember, any radical times itself is just the number underneath. So even further off to the side, I'll remind you, if I had something like root 3 times root 3, we know that that's actually root 9 or just 3. It's the same as root 3 times root 3 is the same as root 3 squared. And when you take the square root of a number and then square it, you end up with that number back right away. So when you have a radical and you multiply by itself, the radical disappears and you're just left with a number underneath. That's great if the number is simple like root 3, or more complicated as something like root 4 plus h. But good news is when root 4 plus h gets multiplied by root 4 plus h, you're left with just the 4 plus h part. That's great. Now my next radical multiplication is root 4 plus h times this. Not as great. They're not the same, so it just goes together. It's a negative times a positive, so it's positive root 4 times root 4 plus h. Doesn't multiply together nicely. But good news is my next part at stage in rainbow is this times this, which is the same multiplication except it's a negative times a positive. So I'll get the same thing but a negative sign. And then the last step is negative root 4 times positive root 4. Well, again, just like that root 3 example, when you do root 4 times root 4, you're just left with 4, or negative 4. Why is this significant? Well, because I multiplied by the same thing but with the opposite sign, it produced a positive thing here, and then the exact negative thing right here. And those are going to cancel. And I'll be left with something much more manageable, 4 plus h, and then minus 4. So you can see the desire to take something that's complicated right here and multiply it by something that's complicated and get something that's not complicated. So all this black notation I would do off to the side, or when you see enough of these, you don't even have to do it. You can actually do all of it in your head. So I'm just going to erase this so I can get back to the spot that I am in my green equation. And I'm going to multiply by the conjugate. So on the top, when this whole thing gets multiplied by this whole thing, I know the answer is a simple thing. It's a 4 plus h. The middle terms are all going to disappear. And then I'll be left with a minus 4. So this rainbow here is good. The next rainbow and the next rainbow cancel, and then the final rainbow stays here. Now, unfortunately, that makes the top look nice, but it doesn't change anything on the bottom. You have this h being multiplied by this. So we're just going to simply write that down, h times that conjugate part. So although the top got easier, the bottom got a little more complicated for now. But you'll see in a second it'll get easier. Okay. So hopefully that made sense, and now I'll be able to do a little bit of simplifying. Again, good news, my constants will disappear, so I have a 4 and a minus 4, so those constants disappear. Things are looking good, and I'm left with just a plain old h on the top and an h times something on the bottom. Well, you can see now why I patiently went through that step, because you'll see I have an h on the top and an h on the bottom, times h and divide by h, cancel. These can reduce to 1. And I'm left with a much easier version of the equation. And one that I can actually sub in 0. If you notice on the line before, I couldn't sub in 0 for h because I had a 0 here. I couldn't here because I had a 0 there. But because they cancel, when I sub in 0 here, I'm not going to end up dividing by 0. And so I can actually take the limit. So I don't need to write down the limit part anymore. It's root 4 plus 0 plus root 4. I can actually make my life a little bit easier now by actually taking the square root of 4 as a nice number. So the square root of 4 is 2, and the other square root of 4 is 2, and I end up with 1/4. And so the slope of this root function at x equals 7 is 1/4. You can see why I chose 7, because it makes it so we end up with a nice little 4, which you can take the square root of later on. I could have chosen a different value for x. It just wouldn't have worked out as nicely as 1/4. You would have had some root signs on the bottom. So that's enough of the examples. You've had a chance to see 4 different versions of it. What I'd like you to do now is practice in your textbook. Page 84, numbers 8 to 10, 11F, and 18. If you look on Moodle, you'll see a couple of solutions to those homework questions, but there are lots for you to practice. And it's more practice using the formula and being able to write the limits. And our next day, we're going to see how we can take this version of the equation and the formulas and make it into a derivative. Good luck.